Hi everyone, Grant for the Flame Learning channel. With the Flame 2020.1 update, another type of machine learning has been introduced into the Flame products. So in part 4 of the machine learning series, you'll learn how to extract the sky out of a shot. So Flame can look at an image and using machine learning identify what parts of that image make up the sky. You can then use that extraction as part of a selective or composite. For example, you may want to grade the sky or perhaps even do a sky replacement. We'll run through 2 examples and discuss some of the finer details as the video progresses. If you would like to follow along, please download the media via the YouTube description or use the link that is currently displayed. So take the first clip of the sign and open it as a sequence. Select the segment and switch to the effects environment. To illustrate the sky extraction, you can use a 2-up view with the manager on the left and the result view on the right. Now the sky extraction workflow will be the same in the timeline, batch and batch effects. So the first step is to select your selective in the manager. Now, even though Flame uses similar analysis techniques for Z-depth and normals extraction, you are not generating 3D data in this instance. The sky extraction is more of a keying function as opposed to a 3D AOV. With that said, in the keyer section of the selective, you can now change the type from diamond to semantic. This enables a context analysis using machine learning. The analysis is set to sky, and all you need to do is press active. Since the outcome is segmentation by contextual identification, the selective is performing this operation within the keying tools, therefore no additional objects or maps are added to the selective object in the manager. However, you will note that the selective object shows the matte in the thumbnail. To see the selective matte in the viewer, hover over the result viewer and press F9 for the selective viewer. So this matte has been generated through machine learning. This is not the same as keying the color or luminance of the image. Looking at the original image with F1, you can see that the sky is overcast and there is no evenness to the color or luminance. So returning to the selective viewer with F9, the sky was identified and extracted from the shot. Now the only adjustments you have is the threshold and the region of interest for the analysis. The threshold allows you to increase or decrease the amount of black and white within the semi-transparent areas. This can help with achieving a cleaner isolation. However, finer details such as trees, leaves and wires may cause a bit of an issue. Similar to the other generators, you need to try it with different shots and you'll identify how this could fit into your workflows. As a tip, you can toggle F9 again and the selective viewer will switch to the selective input, which displays the isolation as a colored overlay. All the selective controls will still work in this view, and you can also shrink, dilate, and blur the output of the selective as a post-process. Once you've created your sky isolation, you can switch back to the result view with F4 and apply any selective effects to the sky. So using the master grade, you can play with the lift, gamma and offset, and tint the sky to make it warmer. When you scrub the time bar, you can see that the sky analysis has been generated for each frame. So that's how to use sky extraction with machine learning. Now let's look at the second example of performing a simple sky replacement. I would recommend doing this in batch effects or batch. Return to the timeline view and press escape or swipe to the edge of the screen to display the reels. Select the beach clip and open it as a sequence. Select the segment and using the Effects button, create a batch effects and make some room between the nodes. Now you can access the Sky Extraction Machine Learning in an image or action node, but it is also available as a matchbox node, which will simply produce a mat. So drag out a matchbox node from the batch node bin and drop it into the flow graph by holding Shift. In the browser, locate the ML Sky Extraction shader. When you select the node and press F4 for the result view, the AI automatically detects the sky and extracts this mat. You can toggle between F1 and F4 to see the before and after. Now the only other controls to adjust is the threshold. This will allow for a small amount of adjustment in the finer details. Finally, this mat will be used to composite the foreground of the beach on top of the sky replacement. So click the Invert button and this will give you the final mat. Now go back to the batch effects schematic and using the Desk node, import the sky clip from the reels. Now you'll perform an A over B composite, but you could also do this in the Action 3D Compositor for more complex workflows. The outcome will be the same in this case. Drag out a comp node from the node bin. Connect the beach clip into the red input and the output of the matchbox node into the first blue input. Next, connect the sky clip into the green background input. Finally, connect the output of the comp node into the BFX output node. Select the comp node and press F4 for the result view. So that is the workflow to extract the sky isolation as a mat and perform a very basic composite with the sky replacement. As mentioned in all machine learning videos, the result you get is based on how the AI model is trained, and hopefully this will keep improving in future releases of the Flame products. There might be a bit of extra work required to get it perfect, but the majority of the extraction has been taken care of by the generator. Don't forget to check out the other features, workflows and enhancements to the Flame 2020.1 update. Comments, feedback and suggestions are always welcome and appreciated. Please subscribe to the Flame Learning channel for future videos, and thanks for watching.